Right, so we're now going to have a look at the tan graph. We've had a look at sine and cos, and I've drawn those actually on the screen here, as you can see, sine in black and cos in blue. I just want to, before we move on, I want to relate this back to what we know about the unit circle and the coordinates as our central angle as it heads off around in a positive direction around the unit circle, and the x-coordinate matching to cos and the y-coordinate matching to sine. So if we just move around, so I just want to look at this first quadrant. As it moves through this first quadrant, we know that the x-coordinate, which starts out at 1, becomes 0, and the y-coordinate, which starts out at 1, becomes 1, both being positive. And let's see how that's now reflected in these graphs. So if we concentrate on the x-coordinate to start with, the x-coordinate is 1 at 0, and that matches cos. So you can see that's reflected here in our starting point for cos at 0, which is what we've got here. Cos 0 equals 1. And what happens as we get closer to 90? That x-coordinate comes back, doesn't it? It comes back this way towards 0, so back it comes. And at 90, our x-coordinate is 0 on the unit circle, so our cos 90 is 0. If we look at sine through that little arc, it starts out at 0 and gets closer and closer as it moves up to 1. So you can see our sine starts at 0 and moves up and hits 1 at 90. And then into our second quadrant, our y-coordinate dips from 1 to 0. And you can see between 90 and 180. In this quadrant here, 1 to 0. So now sine's down here, whereas our x-coordinate goes from 0 to minus 1. So our cos curve goes from 0 here to minus 1, and now we've got our second quadrant sorted out. Now into the third quadrant, and what happens now is both our coordinates are negative. We've got our y-coordinate going from minus 1, our x-coordinate going from minus 1 back to 0 in this little zone here, so our cos now comes back, and our y-coordinate goes from 0, and it goes, as we go this way, drops down to minus 1, so sine dips down to minus 1 here. Then in our fourth quadrant, our x's have become positive again, so from 0 to 1, finishes at 1 at 360, and our sine goes from minus 1 back up to 0. So you can see, and then if we keep spinning around, obviously that then just means that these waves just go on forever, and that goes on in the negative direction as well. Okay, so let's have a look now at the tan graph, and we always say that tan is equal to sine over cos, don't we? So this is just equal to sine over cos, and so what I'd like to do, therefore, is have a look at the sine graph and the cos graph and try and anticipate what tan's going to be from it. So let's just take at 0, for instance, sine 0. Well, where's our sine curve? Sine curve starts at 0, so 0 over 1. So this is going to be, if we're going to plot it in purple, our tan graph, it's going to go through the origin, because at that point, right, so we're taking, just think about it, we're taking sine and dividing by cos. Okay, so sine and dividing by cos, and what do you think at this point here? They're both equal. So at that point, the tan graph will equal 1, I think, because they're both equal, right? But they're both positive at the moment, and you know, this changed a little bit. But what happens here? This is cos. We're dividing by cos. What happens when you divide by a super small number? So divide by 1/millionth as it gets really close. Then it becomes a really large number, doesn't it? Okay, but what happens actually at 90? We're now dividing by 0, because cos 90 is 0. So what happens when you divide by 0? You have problems. So when you have problems with a graph, we see an asymptote appear. And that asymptote says, no, I am not defined at this point, so forget it. We will find that out whenever cos is equal to 0. So we can go across now to the next point where cos is 0 and draw an asymptote there also, because when, again, attempting to divide by 0, which is not going to work. So what we find, the first feature of our tan graph is that it's asymptotic, because wherever cos is 0, tan is undefined. Right, so what we need to do around that is we need to understand that as cos gets close to 0 here, they've got some very large values. So our tan graph does this sort of thing, goes through the origin, and it's asymptotic in this sort of fashion. So it has this kind of shape to it, spins through 180 there, and up. It will continue to do that right the way through 360 there. Okay, and so it is obviously, it goes on forever, but it's in bands of 180 degree bands between minus 90 and 90, 90 and 270, and we've got all these asymptotes. So there's our tan graph. Exercise 13H has some questions to do with tan and how to use your graphics calculators as you did with G to solve some trig equations. So have fun with that. I'll see you in class tomorrow.